How's it going, everyone? So today we're going to be covering the first section of lesson 1.5, which goes over atomic structure and electron configuration. The latter section will be going over Coulomb's law. To start off, let's define the atom. Again, we know protons, neutrons in the center, electrons somewhere in the outside. But now we can be a bit more specific about how exactly they're organized in the outside. Electrons are organized in energy levels. To start off, energy levels go by numeric order. So the first energy level, second, third, fourth, and so forth. It goes up to the sixth and the seventh. Then we have subshells. So a subshell goes by letters. The letters are S, P, D, and F. Subshells are organized as follows. So we have S, P, D, and F. S has one sublevel. P has 3 sublevels. D has 5, and F will have 7. Every sublevel holds 2 electrons. So the number of electrons that can be held in each subshell then becomes twice that value. 2 electrons for S, 6 electrons for P, 10 for D, and 14 for F. If we are to see how do we take this information then and actually classify them, we need to write out the following schematic. And note, quantum numbers and these kind of things has been somewhat removed from the AP curriculum. It's a bit ambiguous as far as to what the course description says, so we'll be going over this rather quickly and then focus on the more important stuff, which is Coulomb's law, second half of the lesson. So here, what you do is there's a trick to finding out the energy, the order in which electrons get filled. Electrons always get filled, or everything happens from a state of low energy over to higher energy, because a lower energy state is more balanced. If you draw diagonal lines running across them, it gives you the exact order in which the energy level would be written. So here I have the first energy level, second, third, fourth, fifth. First energy level has the S subshell, which only holds 2 electrons. Then the next up would be, I started here and now I'm going down following the diagonal arrows. Next would be second energy level, S subshell with 2 electrons again. Then the second energy level again, P subshell now holding 6 electrons. After that comes the third energy level, S subshell, 2 electrons. Next is third energy level again, P subshell, 6 electrons. And then we have a break. We don't go over to the D subshell next. We actually go to 4S. The reason for this is because the 4S subshell level actually has less energy than that of the 3D, hence the need for those diagonal arrows. After that, we go back to 3D, which now has 10 electrons, and so forth. The total number of electrons in a neutral atom is always equal to the number of protons, and if you count these values, you will always get the total number of electrons in your compound. And that's one way of writing out what compound I'm actually looking at. If you go by the number of electrons the entire energy level holds, here you might recognize the values. You have 2 electrons here in the first energy level, 8 in the second, 18 in the third, 32 in the second, and so forth. The periodic table is organized by way of these blocks. So on the left hand side, we have the S subshell. Everything here ends with an S configuration. So it might end in 2S1, 2S2, 3S1, 3S2, 4S1, 4S2, so forth. Here is the P block. Again, they all end in some sort of P configuration. This is the D block, and then right here you expand out to the F block, which we won't be covering nearly as much in this class. Then after that, we've got 3 principles we need to learn. You don't have to memorize their names. You just have to know how to apply them. They are Aufbau's principle, Hund's rule, and the Pauli exclusion principle. What do they say? Well, Aufbau's tells you when we're filling up electrons, we need to go from the lowest energy region to the highest energy region. So in that diagonal order that we had shown before. Hund's rule says that when you're working in a subshell really, you need to singly occupy every sublevel first. What this means is, if I had the 2p region, and we're going to show it as follows: a box with 3 sublevels. If we're trying to fill this up, let's say we have 4 electrons in total, I would put 1 electron here, 1 electron here, 1 electron here, and then the second electron in this one. That's the exact order it has to actually be filled up in. Then, Pauli exclusion principle. In a sublevel, your 2 electrons need to have opposite spin values. So if one spins clockwise, the other one has to spin counterclockwise. We denote this with arrows as such. Also, you always fill out the sublevels with one direction arrow. It doesn't matter which one you pick, you just have to stay consistent with that one direction. So let's try to draw out the electron configuration graph for an atom with 8 electrons. If you're asked to do this, you might see a graph that looks as follows, with your boxes, each box denoting a sublevel. 8 electrons. How can we make this electron configuration? Well, you need to fill out the first energy level, 1s2. Then you go to the second, 2s2. And then the third, well, the second energy level, up next would be the p subshell in that energy level. So 2 plus 2 is 4. How do we get to 8? Add 4. 2p, 4. This is your electron configuration. In a graph format, remember, Aufbau's rule. First you go from lowest to highest. This is my lowest energy state right here. So I'm going to put 1 electron, and I filled up everything. It's only one sublevel there. Then Pauli exclusion says I have to do opposite spins. Now, Aufbau's again. Let's go on to the next one. A certain spin, Pauli exclusion, next spin. On to the third one. At this point, I have 2 electrons right here, I have 2 right here, and I'm going to need 4 to put in here, which means one box will have 2. But how do you fill them up? Well, Hund's rule says that I need to singly occupy first. So I do 1, 1, 1, and then I'm allowed to put the next electron here. And the next electron has to have the opposite spin. So these are my 4 electrons, and this then becomes your electron configuration graph. That's all for this lesson, folks. Thank you very much. Please hit the like button, subscribe, and see you next time.